A meteor moves toward Earth from a distance of 16 Earth radii from the center of Earth. Compared to the magnitude of the gravitational force when the meteor was 16 Earth radii away, what is the magnitude of the gravitational force between the meteor and Earth when they are 2 Earth radii apart? Okay, so let's try to draw this out. I'm going to draw this not to scale. I'll have to draw the Earth pretty small. Let's imagine that this is 16 Earth radii. We want to know what the magnitude of the gravitational force between the meteor and the Earth is when they are 2 Earth radii apart. So like maybe this far. Although now that I look at that drawing, it's probably not a good approximation of 2 Earth radii. Anyways, we can calculate the force of gravity when they are 16 radii apart to be g, the gravitational constant, times the mass of the Earth, times the mass of the satellite, meteor, divided by the distance between them squared, 16 Earth radii. So that will be equal to 16 squared is 256, so it'll be 1 over 256 times g m over the radius of Earth squared. Now the force of gravity when they are 2 Earth radii apart will be g times the mass of the Earth times the mass of the meteor divided by 2 times the radius of Earth squared. So this is all from the law of universal gravitation, which tells us that the force of gravity is the gravitational constant times the mass of one object times the mass of the other divided by the distance between them squared. So this will give us 1/4 times g m over the radius of Earth squared. So we see that when the two objects are 16 Earth radii apart, we have 1 over 256 times this value as the force. When they are 2 Earth radii apart, we have 1 over 4 times this value. So if we take the force of gravity when the two are 16 Earth radii apart and divide by the force of gravity when the two are 2 Earth radii apart, we'll end up with 1 over 256 times g m over the radius of Earth squared divided by 1 over 4 times g m over the radius of Earth squared. So everything in brackets can cancel. We're dividing fractions here, so we can instead multiply by the reciprocal of the denominator. That'll leave us with 1 over 256 times 4 over 1, which is equal to 1 over 64. So the force of gravity when the two are separated by 16 Earth radii will be 1/64 what it is when they are separated by 2 Earth radii. If we reversed this ratio, so we had the force of gravity when they are 2 Earth radii apart and divided by the force of gravity when they are 16 Earth radii apart, we would have 64, which tells us that the force of gravity when they are 2 Earth radii apart is equal to 64 times the force of gravity when they are 16 Earth radii apart. So the answer that we're looking for here is that the force of gravity in the second scenario when they are 2 Earth radii apart will be 64 times as great as it was when they were 16 Earth radii apart.